Okay, good day everyone. So welcome to another pre-recorded video under General Chemistry 2, Chemical Thermodynamics. So in this pre-recorded video, we will be tackling about chemical dynamics and the different types of enthalpy. So later on, I'm gonna explain why is it very important that we know what are the different types of enthalpy. And just to inform everyone, what I gave here are actually the different types of enthalpy that are most used in the field of chemistry. Not most used, pero yun yung pinakakailangan yung malaman. Okay, just for this particular subject matter. So please make sure that you have your calculators with you when you are watching this pre-recorded video, as well as the table of values. So I sent your president another link of the table of values, okay, and that from there you could actually use that one, or you could some of the values that are not present in the PDF file that I gave you are also available in that particular um, website. Okay, so again, your calculators and your TOV, or the table of values. There will be only one target for this pre-recorded video, and that is to identify the different types of enthalpy. And later on, we are just gonna have one example of a problem with regards to the different types of enthalpy. Okay, so I just limited the example into one, but I will be discussing every type of enthalpy. So let's define first what is enthalpy. Of course, we know in our previous discussion that enthalpy is actually denoted as capital letter H. And of course, since we are talking about the change, okay, we are talking about the change, that's why we're gonna use the triangle. Okay, it's a denotion that there is something changing. So that means you need to have two values, the before and after, or the product and the reactant, for you to be able to know what is that change. So we call that triangle delta. What is important about knowing the enthalpy change is for you to know if there is an absorption of energy, or is there an addition of energy, or is there a removal of energy. So in other terms, it tells you the amount of heat absorbed or evolved during the reaction. So again, in our previous discussion, I already told you that energy is neither created nor destroyed. That means that if the particular system, or in that particular chemical reaction, energy is released, then that particular energy was not lost. It was just transferred from the system to the surroundings. So please make sure that you understand that particular topic before proceeding to this one, because you will be needing that one as we go along. So the first type of enthalpy that I'm gonna discuss is the heat of formation. So as you can see in our previous example, remember water in a gas form changing into water in a liquid form. Remember that we are solving actually for the HF prime. So you might be wondering why F? Okay, why are the others, or like in S, which is the entropy, bakit wala siyang subscript? Okay, in here, bakit we have F? And if you're gonna go and surf in the internet, you could actually see there a lot. You have the HF, the H sol. You could also see NEU rather. So what are the meaning of these particular H? Okay, H's. So in that case, those are actually the different types of enthalpy. Okay, the first type of enthalpy is deformation. So that is denoted as the delta HF prime, or the delta HF in simple terms. Now, what does heat of formation say? In enthalpy change that takes place when one mole of a compound is formed from its elements, it is denoted by the change of HF prime. That means you are forming something. Okay? So in this case, for you to be able to have a ferrous sulfide, okay, you will be needing an iron and a sulfur, okay, for you to form a ferrous sulfide. So in that case, you have Fe and S yields to FeS. And in that case, your HF prime value is negative 24 kilojoule per mole. But in these examples, or in these different types of enthalpy, as we discussed, since I just get this from one of a reference that we have in our module, it's actually kcal. We're using kcal here. It's another way of giving, or um, it's another way of writing the unit for the heat formation, okay, or for heat in particular. So it's the kilocalories. So that is kcal. Now, since it is formation, you are actually forming something. So as you can see, it's actually simply as combination reaction. Remember, if you have A plus B, all you have to do is to add the two, because it's a formation, because it's a combination. So that is A plus B yields to AB. So that is the heat of formation. Remember, formation, that would be HF. That is now its um, Kenosha. Next. So another type of enthalpy is the heat of combustion. So for the heat of combustion, because we are talking about combustion here, it is already given that one of your reactants should be oxygen, because you are actually generating fire. Of course, without oxygen, you cannot create fire. And because that is combustion, it is also given that the two products, okay, the possible products that you could have is actually the carbon dioxide and the water. So those are generally one of the few things that you should remember if the reaction is combustion. You should have an oxygen as your reactant, okay, as a partner reactant of a certain compound, and aside from other product, you should have carbon dioxide and water as well, because those are the products of combustion. So take for example in this case, um, in a certain problem, you will just be given with what is the enthalpy change. Okay, that would be the question. What is the enthalpy change of methane, of the combustion of methane? Ganun lang. Walang ibang ibibigay sa inyo. So it's automatically, of course, it's combustion. So you should have a CH4, because that's methane, of course, and it's in a gas form. And of course, you should have O2, because that is the second reactant, because this is combustion again. And of course, your products will always be carbon dioxide and water. And of course, you get these values because you actually balance the chemical equation. You need to balance the chemical equation because you will be needing the numerical values, the numerical coefficients in solving for your change of your enthalpy, or the delta H. So that would be BB yields to C less D and D. So all of those small letters there are actually the numerical coefficients. That's why it's very, very important that you balance the equation first. So for the heat of combustion, if in formation we are actually using delta HF, in combustion we are using delta HC. Okay, so that means you could also see enthalpy changes wherein there is a C as a subscript. That means that the chemical reaction involved is actually combustion. So remember that one. And remember as well what are the different reactant and products in a particular combustion chemical reaction, because in some problems, you will not be given the chemical reaction. You will be the one to write it down. So again, for the heat of combustion, one of your reactants should be oxygen, and the other products, or the products, should be carbon dioxide and water. So if you're going to solve for the delta H using the formula that we have, and of course that would be, let me erase this one first. Okay, that would be delta HC, because it's combustion. So dapat C na yung magiging subscript mo, is equal to you have C, the HC prime value of your C plus D, HC prime value of your D minus A, the HC prime value of your A, B, the HC prime value of your B. So, medyo mahaba lang siyang isulat, but it's actually not that hard kasi all you have to do is to do the mathematical operation involved. So, in this case, if you're gonna solve it and if you're gonna pause this video, you should generate an answer of negative 21.0 kcal. But not HF anymore because this is a combustion reaction. Your change in enthalpy should have a subscript of C. So therefore, you should have delta HC is equal to negative 21.0 kcal. What does it mean when you have a negative value of your delta H? So that means there is a release of energy. Again, the perspective that we are seeing here is in the system. So that's why it is negative because there is a release of energy from the system to the surroundings. Another type of enthalpy is the neutralization. So from the word itself, neutralization, that means you are neutralizing something. And what are you neutralizing? Of course, we know when you are neutralizing, there should always be an acid and a base. Okay? Kasi nga you're looking for the neutrality of the two. So in this case, one of your reactants should be an acid, and the other should be a base. So in this case, you have the nitric acid in an aqueous solution. When you say aqueous solution, that means there is an addition of water in your nitric acid. One of the reasons is that, of course, it is volatile. It's very dangerous if you have a 100% nitric acid. That's why um, you need to create an aqueous solution out of that by adding water. And of course, the sodium hydroxide solution in an aqueous form as well. So again, there is a presence of water. And that, it should yield to sodium nitrate and water. So in neutralization, of course, we know that you should have an acid and you should have a base, and your product should always be a salt and water because you are neutralizing. So in this case, when you say heat of neutralization, if the chemical equation involved is actually neutralization, then therefore the enthalpy change that you are looking for is the change of your H and EU. That means you are looking for the change of enthalpy in a neutralization process. And in this case, it is nitric acid and sodium hydroxide giving off a salt in a form of sodium nitrite and water. So if you're going to pause this video and if you're going to solve for the change of enthalpy of this chemical reaction, you will get a negative 13.69 kilocalories. So that means there is a release in energy coming from the system. And what are our system here? Of course, it's our reactant. Okay? So that is for the neutralization. Again, for neutralization, you should always have an acid and a base because you are neutralizing, and your product should always be a salt and a water. Last under type of enthalpy. Actually, there are a lot of enthalpies, but in this pre-recorded video, I'll just be discussing the four. Meron pa yung iba, so I guess you will just have that in a higher chemistry. But in this case, in our subject, I will just have this four because this is the most important one. The last one would be the heat of solution. So the enthalpy change here is actually just you're creating a solution. You are making a solution. So take for example, in this chemical equation, you have magnesium sulfate in a solid form and you add it to water. So of course, definitely we know that we could actually generate a solution out of that. And actually, it should be in an aqueous form. Why? Because we are adding water. Okay? So magnesium sulfate added to dihydrogen monoxide, and that would give you a magnesium sulfate in an aqueous solution. Okay, so of course, since this is solution, you are not going to use delta HF because that's formation. You're not going to use HC because that is combustion. And you're not going to use HNEU because that is neutralization. For heat of solution, you're going to use delta HSOL. Niece, how about the solving process? It will be just the same with the delta HF. You are still looking for the sum of the products of your numerical coefficient and the values, okay, of your product minus with your reactant. And there you could always have your delta H. Kaya nga sinasabi ko sa inyo, this one is the easiest in thermo because all you have to do is to subtract and to add and to multiply. Okay, no other complicated formulas such as stoic. So all you have to do is to familiarize yourself on the process, and please make sure to review your answer very carefully because there will be cases wherein sa sobrang dami ng values dun sa TOV natin, baka magkamali kayo ng masulat. And make sure that you write the correct form of the compound because if that is solid, it will have a different delta H value. If that is liquid, if that is gas, if that is aqueous solution, magkakaiba po sila ng value. And please do remember that this is just strictly at at 25 degrees Celsius or 298 Kelvin. Okay? So, if the problem is asking you the change of your H and that given in a 32 degrees Celsius room temperature or in a temperature, that means you cannot use the TOV that I gave you because the TOV that I gave you is just standardized. That means it should be at 25 degrees Celsius. So, in that case, you cannot solve that unless you search or you surf the internet looking for the values, the standard values or the standard quantities of your enthalpy of the compounds, of every compound under 32 degrees Celsius. So, make sure to read the problem very carefully. Okay, so in this case, if you're going to have this enthalpy, and if you're going to solve this enthalpy change of magnesium sulfate and water, you will have negative 20.28 kilocalories. That means there is a release of energy from the system to the surroundings. Again, our perspective is the system, not the surroundings. Okay, so again, I have discussed this one already in the previous pre-recorded video. Again, when you have delta H, and that would be positive, meaning that the enthalpy of your product is greater than the enthalpy of your reactant. So that means heat is absorbed. Okay, that means the energy or the heat is coming from the surroundings the um, to the system. And because our perspective is the system, that means the system is the one absorbing. So it's positive kasi nadagdagan siya. If that would be in physics, negative siya because the perspective is in the surroundings. So that means negative naman yun sa kanila. Okay, but in here, again, it should be positive. Now, for your delta H, it's negative because it means that your HP is less than your HR. And because heat is evolved, then therefore it's exothermic. If your delta H is positive, then therefore it should be endothermic. So remember those two important reaction. The endothermic and the exothermic reactions. So let's have an example involving a problem under the different types of enthalpy. So, ganito lang yung ibibigay sa inyo. There will be no chemical equations at all. There will be no phase. That means you don't know if that is solid, if that is liquid. So, that means you need to figure it out based on the problem. So, in this problem, you have what is the enthalpy change of the neutralization of hydrochloric acid and sodium hydroxide solutions. So, we know those are both solutions. So we could actually deduce that both of them are actually in aqueous form. Okay, so your HCl, which is now your acid, is in aqueous form, added to a sodium hydroxide solution, again in an aqueous form, and that would give you a salt. In this case, if we're gonna do the A, B, C, D, okay, this is just simply double displacement, you will get NaCl, which is your salt. And of course, hindi ka makakabuo dyan ng solid talaga na salt. Okay? It should also be in an aqueous form. And of course, since this is neutralization, your other product should be water. And that should be in a liquid form. Hindi siya aqueous. Liquid form. Okay. Now, of course, since we have now the chemical equation, the next step is to balance the chemical equation. As you can see, it's already balanced. You have 2 hydrogen in the reactants, 2 hydrogen in the products. You have 1 chlorine in the reactant, you have 1 chlorine in the product. Sodium 1, sodium 1. Then your oxygen in the reactant side is 1, and in the product side is 1. So it's already balanced. So no problem at all. So we know that the numerical coefficients of your A, B, C, and D are all 1. So let's now solve. So since this is neutralization, our H will have a subscript NEU to serve or to denote that the reaction is actually neutralization. And that would be is equal to the bracket of C. Then you have the H prime NEU, NaCl aqueous solution. Remember to write it down kasi baka maguluhan kayo when you look for the values. Then you have the D. Find the H value of your D, which is in this case is water in a liquid form. And minus, you have now your A, of course. And you have the NEU prime value of your HCl aqueous solution. Plus, you have the 1 HNEU prime value of your NaOH in an aqueous solution. So there. Then the next step that you're gonna do or that you're gonna have is to find the different values of every enthalpy. So you have now, for C, that would be 1. 1 times the enthalpy value of your sodium chloride in an aqueous solution is actually in the second link that I sent to your precedents. So, dun nyo lang siya makikita because in the PDF that I gave you last week, wala siya. So, nakailang tingin ako, wala tayong values dun. So, I searched for the other values and I saw another TOV. So, kindly keep that one. That would be very, very useful for you as you go in college. So, you have now negative 407.3 kilojoule per mole. That's the unit under H. Okay, so you might be asking me, why are we not using the kcal? Again, we just used the kcal a while ago because that was the example in the reference. So there are a lot of units that could actually be used for the enthalpy. The other one is kcal. In this case, we're going to use the kj per mole. Then you have plus. Your D is just 1. That's the numerical coefficient of the second product. And you have negative 285.8 kilojoule per mole. Minus, you have 1, negative 167.2 kilojoule per mole. Plus, negative 470.114 kilojoule per mole. Just be conscious on writing the negative sign, the bracket. Kasi kapag maling lagay mo lang siya sa calculator, you will generate a different number. Okay? Because of the sign lang. So, careful lang tayo. So, your delta H and EU value will be equal to negative 55.786 kilojoule per mole. So, this is now your answer. Okay? So, that means it's negative. So, it releases energy. And since it's negative, that means it is exothermic. Okay, so that's it. So just remember you need to identify first what type of enthalpy change is the problem talking about. Then right after that, you write the formula, you write the chemical equation, you balance the chemical equation, you identify all the values of your enthalpies, then all you have to do is to put all the values in your calculator and you'll now have your answer. So that's negative 55, it's releasing of energy and it's exothermic. So if in this problem you were asked what is the combustion or the change of enthalpy in a combustion reaction, then definitely you should have an oxygen in your reactant, carbon dioxide, and water in your products. So that's it. And that would be the end of our pre-recorded video involving the types of enthalpy. So I hope that you learned something. For the next pre-recorded video, we will be tackling about entropy naman. Then the next one would be Gibbs free energy, and the last one is the Hess's law. So there. Please make sure that you comment down below if you have questions so that I can read that one before we start our meeting in a synchronous meeting, and that I could actually answer that before I start with the new topic that we have, which is kinetics. So thank you so much for watching, and I hope that you learned something. You can always approach me in the MS Teams or during the consultation period if you have questions. So goodbye everyone.